Hey again, this is Jess for mini lecture number 8 for Computer Science 163 at the University of Wisconsin-Eau Claire. We'll be talking today about simple algorithms for arrays and vectors. We'll be covering stuff discussed in 6.2, 6.4, and section 6.7.4 in our textbook. Before we begin, make sure you understand what is an algorithm, what are vectors and arrays, what are the similarities, differences, and how do you use them. Also, how do you pass an array or vector by reference, and what does that mean? So when we talk about simple algorithms, we'll be giving a list here of algorithms that we'll talk about today, and any of these algorithms can be done either with a vector or with an array. Now, algorithms are usually really good things to be writing functions for, because you can use an algorithm for one problem, but you can always use that algorithm for another problem too. And once you've written the code for an algorithm, you don't have to write it again. It's there for you. So if you code this algorithm once, you can use it anywhere else in your code. And we'll see a little bit of that today too. The first algorithm we'll look at is filling an array or vector with the same value. So filling an array all with zeros or all with 99s. The next one is to copy all values from one array or vector to another. Another is to calculate the sum of all elements. Another is to calculate the average of all elements. Then calculate the minimum value of the set of all elements, and then calculate the maximum value. The first one is to fill an array of doubles, or to fill a vector or array with all of the same value. So we want to fill an array of doubles with a specified value. Now throughout today's lecture, we're going to have a lot of chances for practice, and so I want you guys to try to implement each of these before I get to it. So for the fill algorithm, based on this one line alone, try to pause the video and try to implement it yourself. If you didn't pause it yet, here's your second and last chance to do so. Pause here, try it on your own, use this as the method signature for the arrays. All right, assuming you did pause, we'll go on. What I want to do is I want to take an array of doubles, and I'm going to pass the size of the array, because remember, we need to know how big that array is, how many values it has in it. And then we also need to have the value, fill value, that we're going to pass to that array, or to this method, and that we're going to fill all of its values with. So we basically set up a simple for loop using index as a counting variable and iterate from 0 to array size -1. And for each value that there is in the array, each index, we set that array element equal to fill value. That's it, we return, we're done. Now notice we've not included the return. That's because there's no return type, it's void. So in that case, the return statement is optional. Next, I want to challenge you to try to do this with with vectors, or a vector of double. So implement the same algorithm now with a vector. Pause and then continue. So here's the method signature. Now remember, for the array, in the method before this, the array is passed by reference just automatically. That's just how arrays are passed. It passes the memory address or the location of the array in memory, and so we're using a reference of that array. Here, if we were to just pass the vector of doubles called vec without the little ampersand, we would be passing it by value, and it would make a copy of that vector. We want to make sure that we change the values of this vector, so we need to pass it by reference. So here's what we get, and really it looks almost identical to the array algorithm. The only difference is really in the method signature and then the name. And then also the maximum size. Notice we didn't have to pass in the array size, we instead passed in the vector itself, and then we were able to ask the vector, what's your size? Now there's an easier way to do this for vectors. Because vectors are a class, they have a lot of built-in functions, and so there's a function that will do this for you. I challenge you, first of all, notice that the same method signature is here, but we're going to change the body of this fill function. Otherwise, it's going to be identical to the one right above it, the middle one. So I challenge you to try to look this up and see if you can figure out by going to that cppreference.com website and looking up the vector class and see if you can figure it out from there. Good practice. If not, here we go in 3, 2, 1. It's just a simple one-liner of code. So vec equals vector double, and then fill value, and then vec.size. This is what's called a constructor, if you look on that website. And it will construct a new vector with a bunch of values equal to fill value. And then how many of those values? We're going to say vec.size. So the input vector, we're going to ask what its size is, and then we're going to figure out, we're going to fill it with that many values, and each of those values are going to have fill value. So, simple one-liner. The next algorithm is the copy algorithm. Now for the copy algorithm, we're going to copy all of the values from a source array into a destination array. We're going to assume, for our purposes, that both arrays have the same size. And so what I want you to think about is, we're going to do this with vectors first and then arrays to give you practice going both ways. What do you think the method signature will be? Pause here and I'll show you in a sec. What do you think the method signature is? What return value, what input parameters will there be? 3, 2, 1. For the vector, it's this. We're passing in a constant vector source. We're passing it by reference for efficiency, but it's constant because we know that the source vector shouldn't change. We're just reading the values from it. We're not changing any values. Then we're passing in a destination vector called dest, and this one we need to pass by reference because, well, efficiency, I guess, but we're writing values and we want those values to, when we change those values, we want those values to stay changed when this function leaves. So we're passing by reference for that reason here. So if you haven't, so try pausing it now and try to write this method on your own if you can. 3, 2, 1. All right, so what we're going to do is, just like before, we create a simple for loop and we iterate over each index or each element, or rather, we're iterating over each index in this array. We're saying for each index, copy the value from the source array at that index, or the source vector at that index, to the destination vector at that index. Simple, easy. Now, this assumes that both vectors are the same size, which we said we would assume. But if this isn't true, we can do it. We could modify this a little bit and make it fancier, as I mentioned there. Won't worry about that for now. Let's do it now for arrays. Now for arrays, I'm again going to ask you guys to pause it here and try to write this method for arrays. Think about what the return type should be, what the parameters should be, and how you implement this. 3, 2, 1. All right, so here's what that method signature would look like. Hope you got that much. And there we go. So again, the source array is, we're using the const keyword because we're only reading from it. And then double dest, we're not using the const because we're writing to that. We're changing the values of the destination array. Other than that, this method looks exactly like the vector version of copy. Now, because vectors are cool, they have their own built-in method of doing this. And in fact, they have it so fancy that you don't even need to assume that these vectors are the same size. You can just use the equality operator, the assignment operator, the equal sign, and the vector class redefined that operator, which is a cool function and thing that you can do in C++. One of the coolest things about C++, in my opinion. So they redefined it so you can take a vector object and you can set it equal to some other vector. So here the destination vector is being assigned equal to the source vector. It's going to copy that entire vector no matter how big or small or empty it is. And it's going to make that new destination vector be equal to that, which is cool. On to the sum algorithm. We're going to do this first for doubles, and then we're going to do it for vectors. But again, what I want you to do is pause here, and I want, if possible, well, first of all, do the doubles, but then try to do the vectors version. What I want you to do is write a routine that will sum up all the numbers in an array. So think about what the return type of this function should be. Think about what the parameters should be, and think about how you're going to do this. Try coding it up, see if you can get it to run and compile. 3, and then I'll show you the answer in 3, 2, 1. Here we go. Now the difference between this and some of the earlier algorithms, we still got this for loop there, but we're going to have this value called double total, and we're going to start counting at 0. Then in the for loop, we're going to add whatever new element of the array we're in, iterating over all of the elements. One by one, we're going to add those elements to this running total. And at the end, we're going to return that value. Great, cool. And notice again that the array is declared as a const double array because we're only reading from that array. We're not changing it. Now, let's try to do this with the vector version. Again, I want you to try doing this on your own. So pause it and try to write the vector version of sum. 3, 2, 1. Okay, so here we go. Notice that you've got a const vector of doubles. We're passing by reference again, and we're returning a double. And this is really just the same algorithm. So pretty much the same for arrays and vectors. It's just the method signature that looks just a teeny bit different, mostly. Next is the average method. So for this, we're going to add up all of the values in an array or a vector, and we're going to divide by the number of elements in that array or vector. So go ahead and try to implement this on your own. Here, I want you to pay special attention and say, what should the method signature be? There could be different ways of doing this, but try to get that method signature as exact or as well done as you possibly can for both arrays and vectors. If you're not sure, that's okay, but please do give it a shot. This will be really helpful to you. Good practice. So in 3, 2, 1, I'm going to show you the, I guess that was my 3, 2, 1. I'm going to show you the vector version. So 3, 2, 1. We're having double, average, and then const vector vec. Because again, we're only reading from that vector. It's just like the last slide. Now here, notice that we use the sum function, and that lets us return this value as a one-liner. So because if we defined the sum function earlier in our code, i.e. on the previous slide, all we need to do is we need to call that, that function right there, and sum vec here returns a double, and then we return that result divided by vec.size. We get a double, and we return that double. Pretty cool. So this is why we want to make these functions and write these algorithms. It's because we can then reuse them for other purposes. And there's a lot of other times when you want to be able to calculate the sum of a vector, right? Or the average. So it's really useful stuff. So next we're going to do the array version of this. And so I'll show you how to do that. Pause it again if you haven't already done this. I'll give you a sec to write that up. And in 3, 2, 1, I'll show you. Here's the array version. Again, we're passing in a const double array because we're only reading from that array. We're not going to write to it. We're returning a double, and we're going to call the double version of sum now from the previous slide. So that version of sum required us to pass the array and the array size. Pretty cool. And it works. The minimum function is a little bit harder than the previous algorithms. So in the minimum algorithm, what we want to do is we want to get the minimum value and return the minimum value of all of the values in an array or a vector. So again, try to think through this and think how you do it. Write down the steps if you want in pseudocode. Better yet, try to implement them for an array. I'm giving you the method signature here because it's a little bit more complicated, this algorithm, than the previous ones. Not much, but a little bit. So pause it, see if you can figure it out. If you're stuck, watch on, but give yourself a sec to think. The key here is that we want to think about what's the lowest value so far. We're going to iterate over all of the elements one at a time, and each time we're going to be saying, hey, is this value lower than the lowest value that we've seen so far? So we're going to start by looking at the first one. Is this the lowest value we've seen so far? Well, it's the first one we've looked at, so yeah, why not? So that could be the biggest element in the array, but we're going to start off by saying that's the lowest we've seen so far. And at the end, we're going to return whatever that value is. That's the lowest so far. But along the way, if we come across a smaller one, we're going to set that lowest so far equal to that lower value. So if you think you have enough to do it the rest of the way, pause here and write it out. And then otherwise, we're going to continue on. We're going to do a for loop. And we're going to iterate from index 1 to the size -1. So whereas before we've been iterating starting at index equals 0, now we're going to be starting from index equals 1. And that's because we've already looked at the very first element, array 0. Now we have to start at the next one. And then we don't want to have to check the first one again. We're going to start at index 1 skipping the first one because we did that up above. And in this loop, every time we look at the next index of this array, we're going to ask the question, is this next index lower than or less than the lowest that we've seen so far? And if it is, if that's true, then we're going to set lowest so far equal to this new lower value. Pretty cool. And so at the very end, we return that lowest value, and we're done. Give yourself a pat on the back if you've got this so far. Now, go ahead and try to implement this for the vector based on this, and see if you can. So pause it in 3, 2, 1. Here's the vector version. And this is almost identical. In fact, I copied and pasted from the paragraph above, or function above. Paragraph, function, you know what I mean. The only difference is the method signature and then the name of the array or vec. So very, very, very similar. It's the exact same algorithm, the exact same steps. It just looks a tiny, tiny little bit different because we're using a vector instead of an array. Next is the maximum function. In this algorithm, we're going to be returning the maximum value of all of the elements of an array or vector. This is almost identical to minimum, and so what I want you to do now is to try to code this up both for the array and the vector versions. If you're stuck, try looking at the code for the minimum function for the array and vector. Otherwise, this is something I expect you should be able to do. We've tried this, we've got the minimum. If you understand that, you should understand how to do the maximum. But let's do it anyway. So here's the maximum function. Again, very, very similar to the minimum function. What we're going to be doing is we're going to be keeping track of which element is the biggest that we've seen so far. So we'll start with the first element. Is that the biggest we've seen so far? Oh yeah. So that's our biggest one so far. And then again, we're going to be starting from index equals 1. So we've already looked at the first one. Now we're going to look at the second, and we're going to compare that second one to the first one, the greatest we've seen so far. And so on and so on, always updating it and keeping track of the greatest we've seen, and at the end we return it. Awesome. So go ahead, pause here if you haven't done this for the vectors already, and I'll show you how to do that in 3, 2, 1. All right, hopefully you got it. Hopefully it's working for you. And yeah, that's the maximum function. Now that we've got all those algorithms looked at, here are some closing thoughts. First, vectors and arrays are very similar, but yet they're different too. Arrays in practice are slightly faster to use than vectors, even though vectors use arrays, a special kind of array under the hood. Arrays are among the fastest ways that computers can manipulate data, so it's good to be able to use them. Vectors, they do a little bit more overhead, they use a little bit more memory, and because of this overhead, it's a tiny bit slower to use, and they use a little bit more memory. However, there's a huge difference in terms of the things you can do with them. It can really make your life as a programmer a lot easier if you use vectors. And so for my own work, whenever I'm programming in C++, I always prefer to use vectors when I can. In fact, when I program in Fortran now, I made my own vector class. I actually called it ArrayList after Java, but it basically has the same functionality as a vector. Basically, if you're familiar with Java, an ArrayList and a vector, a Java ArrayList is essentially the same as a vector in C++. Next, algorithms for both arrays and vectors are basically identical, and that's because under the hood, a vector and array, you can think of them as almost the same kind of thing. It's just a different skin, if you will. The same steps. An algorithm really describes how what you do to numbers to change them, and so how we represent those numbers is just the skin. It's just syntactic sugar, as you might say. It's just how it's presented to you. So those things are different, but the general steps are identical. Finally, because vectors are a class data type, they've got all kinds of pre-written functions to help make your day awesome. So if you can, prefer to use those over arrays most of the time, if you can. They're really awesome, and I encourage you to check them out. Now some review questions. We've already done a bit of review and practice, so there won't be any practice problem today. But here are some review questions I want you to think about. What are the steps for each of these algorithms? Could you write them on your own? If I were to ask you, write a copy algorithm on the next quiz or test, could you do that? Could you do it for an array or a vector? Or if I gave you a new algorithm using, say, a vector, could you then convert that to an array using, or an algorithm using an array? Or if I gave you an algorithm, a new algorithm that you haven't seen that uses an array, could you convert that to the same kind of algorithm but using a vector instead? So those are my closing thoughts for you. If you have any questions, shoot me an email, and I hope you guys are doing great. Thank you for your time and attention. Bye-bye.